So, hello, welcome to another episode of Beam There, Done That. Of course, I'm back with my glorious co host, Francesco Cesarini.
Hi there, Francesco. I'm also co-host. Today we will be talking about the why, how, and what of web framework. What constitutes a web framework? What features make web frameworks on the Beam unique? And with us today, we've got Adi. He's just published a book called "Build Your Own Web Framework." Adi, welcome to the show. Why don't you introduce yourself?
Yeah, sure thing. Thanks for having me, guys. I'm Adi, engineer at The Score. It's a sports betting company. And yeah, I published a book, Build Your Own Web Framework in Elixir, a few years ago. It's been, what, three and a half years now. So yeah, perfect time to revisit that book.
Yeah, so Adi, I reached out to you because we're doing a new podcast. Adi and I used to be on Elixir Mix. I guess we're still going to be on it. That's something to discuss. Oh, and I remember your book came out. For some reason, I'm not allowed to read it because I'm not in the right country. I'm not sure what's going on. This is something I really want to check out because I'm also curious about, the internals and how things kind of work. But I was kind of curious though, where did you get the idea and just said, I need to actually build my own framework? Like, where'd that kind of idea come from?
Yeah, it wasn't necessarily that I need to build my own framework. It is so when I started programming, I started with Ruby on Rails, and Elixir was still just coming out. It was 2016. Well, Phoenix was just coming out. Elixir was out. So there was like a lot of from computer science doing like C and all these things, where things are like completely transparent. You have control over everything. It was a huge kind of shift of perspective to like do like Rails, right? And then Phoenix followed. At least the first version followed very the magic aspect of that. So I just wanted to demystify it for myself, like see what's happening underneath. And so yeah, I read through the code. It was just Ruby at the time, right? Like Rails was pretty simple to read through. Good learning session for me. And then kind of gave that session to others. Like wrote like a presentation. Talked about it with my coworkers. Gave a couple talks and like meetups around here and did the same with Phoenix. And so I did it enough times that people had suggested, hey, maybe just write a book, right, about this instead of like building a very small version of Rails or Phoenix live during a talk. Let's be cool to dig a little deeper into it. So the whole purpose here is to as a learning activity, people can learn how Phoenix is built instead of just being a user. They could understand things more in details and maybe contribute. The more people who understand Phoenix, the more we can improve it, and the better it'll be for the community. That was the whole goal.
Oh, because you wrote this book and you got into the internals and all this stuff. Do you find yourself saying like, "Oh, I know exactly where the problem is"? Whenever you find some kind of bug in your code or in the framework yourself, and you're submitting patches, or it's just more interesting that you got into it than anything else?
No, no, nothing like that. Phoenix is first of all, pretty awesome. Nothing is, no code is perfect, right? Neither is Phoenix, and it's a lot of different issues. You can talk about that are there in Phoenix, but overall, it's amazing. Nothing glaring in my eyes, at least when I looked at the code. And also, it's a lot of code, right? Like you can't just like boom, look at the code and here's the bug, right? So it at least if there was a bug, it wasn't apparent. Yeah, I mean, I don't want to kind of put any other libraries down or anything, but like other frameworks that I have read through, learned about, Phoenix, I guess, are ahead of them, and for how much it does, right? To make it cleaner, better, whatever you want to call it, you might have to like cut down a lot of its features. I think there are smaller web frameworks in Elixir, right? So yeah, but for what Phoenix does, I think it's pretty awesome. It's not easy to achieve that with the level of code that Phoenix has.
What did you believe about Phoenix before writing the book that turned out to be wrong?
I think I probably underestimate how hard it would be to write Phoenix, right? That's probably
Mm.
one. I had a lot of plans for my book, like live view and stuff, and live view was just coming out when I started writing the book, and it is a lot. Like it's a lot. There's a lot that Phoenix does. I used to be a developer, at least when I started the book, where I feel like boom, I could write that on a day, right? Like stuff like that. So I I've respected Phoenix, but I thought maybe a few weeks I could probably write something like that. No, that was a good humbling experience. It's not easy at all to. I mean, it's very difficult to write it. Very difficult to maintain it. And not even mentioning the open source side of it, right? Like answering questions and all that stuff on your free time, right? It's incredible. So I already had respect for Phoenix, and that respect probably double the triple after writing this book.
Brilliant. Now, when we say web framework, what layers are we actually talking about?
That's a very good question. I don't think there is a definition of that, right? Like at least what I was considering here, there's the front end UI rendering layer, the application layer where all your logic exists, routing and all that, maybe like some base server logic, and using Ecto for persistence, right? That's kind of at a high level what I'm talking about. Like maybe not quite MVC, but equivalent of an MVC. So like using Ecto as almost your ORM and the model layer. It's like simple ways to manage view controller. That's pretty much it.
Now, I'm kind of curious though, like, why do developers hit a wall going from mid-level to senior when they're using a framework like Phoenix?
I mean, that's a good question. If you could do a podcast on that itself, but I think at a high level, it is from assuming that the developer has enough drive and they spend enough time, all that, right? Like the behavioral side of it, and desire to be a senior, of course. I think they're probably in Phoenix in particular, the whole magic that it does probably creates a longer bridge for them to cross to really gain full understanding. Because I mean, in my opinion, it's hard to be a senior if you keep on following conventions, especially with Phoenix, right? In Ruby we say Rails we say convention over configuration, but I think in Phoenix maybe it's a good place to start. But I think you need to be able to tweak things to kind of suit your use case, your scale requirements, or if there's like a you know custom small application you want to build, a sidecar for your application. There's so many use cases that could come up that Phoenix allows for configurability. So you do need to start crossing that bridge of like, wait, instead of just being a user of the DSL that Phoenix provides, let me try to understand the framework and like try to configure it. So I think that could be one of the reasons people might not be transitioning to that senior title, or like or feel like they're senior, because like I said, in Rails you could probably do that and be senior because that's like more accepted in Rails community. But Phoenix does need a bit more knowledge, in my opinion. And people, you guys can feel free to disagree. It's sorry, go ahead.
I I perfectly I see it, and what I often see as well out there is, how many users are actually submitting patches, and how many and I see that in a lot of different kind of frameworks and open source applications, and the ability to submit patch, understanding how the internals actually work, I think is what makes it, is what really makes you a senior with such frameworks. Feel free to disagree, but this is what I've been seeing out there. And it's also, I think, one of the challenges with Phoenix is that it hides so much of that complexity, from the end user. So you're as far away from the bare metal as possible, and you can be an amazing, really prolific, Phoenix developer without understanding concurrency.
Yeah, very true.
You talked a little bit about, like the complexities behind it, right? I think a lot of complexities, they tend to be hidden behind some kind of like magic and some special sauce, like the way they write things. I know that Chris wrote a book about macro, metaprogramming, and I think what they say about it, is it macros or is it metaprogramming or both, where it's like, don't do it. If you really need to do it, then do it like this or something like that. But coming back to that, like I kind of think of that stuff sometimes is a little bit magical. Do you feel like all that magic is something that's a liability or something that actually is a great feature to have?
No, not a liability at all. I mean, I think in an ideal engineering world, you have people who have a lot of time, patience to, put things together, write bottleneck code, right? Like learn all the details, and you won't have any magic, I guess, to deal with, right? But I think in real world, that magic helps a lot with adoption. And it might not be easy as a new developer to just build a web server using Cowboy, right? And like not having a router and like using the Cowboy's routing mechanism and stuff like that. As a first time developer, it's a lot of work. I think Phoenix provides a perfect DSLs, especially the router DSL. I mean, there's some a reasonable critique of that, right? But I think overall, I think it's very good. Without that, the adoption would be very hard. And I think Chris leaned into the whole Rails idea. There's like a rumor going around. I'm not sure if it's true that Chris cloned Rails repo and started tweaking the Ruby code replacing it with Elixir code. I don't believe that, but maybe there's some truth to it. It's probably exaggerated, but yeah, I think it's the same idea as Rails. If what you're doing is too complex, right, you can hide it within that metaprogramming or DSL layer. That's why Jose added metaprogramming to Elixir, right? That's the whole purpose of it. What's good about Elixir, unlike Ruby, is that it has a lot more guardrails in place to prevent really weird stuff from happening. You cannot open classes, you cannot open modules and like redefine. Well, you can, but not easily, right? So Elixir has a lot of guardrails preventing stuff like that from happening. So I don't think it's a liability at all. I think it is the power of Phoenix allows it for adoption, not just by developers but also by companies, because it provides very high productivity. 0 to 1 is very fast for Phoenix. I've used it for startups. I encourage startups that I advise to use Elixir as well because of the productivity aspect of it.
How much of Phoenix is elegant comes from the Beam? How much of it comes from Elixir? And how much of it comes from Chris's design choices?
Yeah, so I think a lot of it, again, I haven't read through the code in recent months, but when I was writing the book, I didn't notice a lot of the separation between your interface, the DSL, and actual logic. It was starting to get a little gray. If assuming that those two are completely separate, we can obviously say the whole DSL is very much powered by Elixir. A lot of what Phoenix uses, it used to use Cowboy at least at the time. I don't know now moved to Bandit by as default. But yeah, Cowboy, Ranch, like relying on Ecto, which I think initially it was coupled with Ecto, right? And then it completely decoupled itself from that. And yeah, I think just using those libraries, plug, EEX, that were already written and just like nicely packaging it together. That's pretty much what it does. I mean, like I said, there's the whole DSL, which I think the layer separation wasn't as clear as maybe if you ask Chris to rewrite it, he might rewrite it differently. Other than that, it's what from a code what it does. It's pretty simple.
Great. So if you go back to my early days when I was an intern at the computer science lab, there was a protocol called HTTP, which back then still hadn't reached 1.0. It was still at 0.9. How did my colleagues at the computer science lab learn HTTP? Well, they went in and wrote their own web server. And I remember tinkering with Torbjörn Turnquist's web server, which eventually became Inet, playing around and catching the URL, playing around with the referrer logs. It was a lot which you could do on a low level. What surprised you the most? When about the possibilities when building an HTTP server from scratch.
Yeah, just again how easy it was. That was probably one of the most surprising for me, at least as someone who started developing in 2016. Cowboy and Ranch, but specifically what Cowboy did felt very magicy to me because I wasn't very familiar with Erlang, never looked at the code, and while I was familiar with Elixir metaprogramming, so Phoenix I could still demystify at a high level, but Cowboy it was really you know what it does. It's magic, it just like creates connections, manages it. How does it do it? But then I realized it's all Cowboy does is creates a TCP connection using Gen TCP, which again every language has a version of. Erlang one does a few more things on top, and just how Gen TCP works, it just has that listen, right? Just listens to once a socket is established, listens to any messages on that socket, and sends a message back. That's all Cowboy does, and just based on a few headers, based on a few different message types, it knows how to has a bit of a routing layer to it. Another really interesting thing was just HTTP for me, how it's interpreted. It's just text with few headers and an extra line break, right? That also was quite interesting, and that the same thing worked in other languages as well, the same exact document, and it blew my mind, like because we don't think in terms of such low level as a modern developer. So yeah.
Exactly. I've seen that level of abstraction, especially when we were, I mean, most of the airline community, their background is telecoms, and so they were working with really kind of low-level packet switching, and get the whole stack. So, was this the biggest misconception you think developers might have about HTTP?
Yeah, I
That
think
it's
it's one of them.
complicated and it's hard to learn. Yeah.
Yeah, it's one of them. Yeah, because again, we never have exposure to it, right? Like it's not. Yeah, it's the yeah. That's the biggest misinformation people have. But it's probably the simplest part of the book. That's why I start with that. Like building your web server was actually one of the simplest things, especially in Erlang or
A
Elixir.
following question on this, how does the Beam change, the way you think about a web server and the way you think about designing a web server?
That's a great question. So I think first of all, the whole listen loop is pretty cool. Very few languages could do that, right? Like the whole tail call recursion. That itself simplifies your because that's what you want a web server to do. You want it to keep listening. You don't want like any sleeps. You don't want any weird multifunction calls, right? You want it to keep listening, and the best way to show it in code is that a recursive function that calls itself that Erlang is one of the few languages can do without any other problems. The other part is the ranch part, which we haven't done in the book much. How easily it's able to create a pool of processes that keeps connections alive and manages them. Those socket connections. Again, like keeping state within each connection. There's a lot that you could do in other languages, but just so easy and again like process oriented thinking, right? Like that Erlang promotes. It's so easy when you think in terms of processes. Just to spin up a few gen servers that are supervised, and boom, you have a connection pool to play with. It's
Yeah.
pretty awesome. It would be very hard to do this in like say Ruby. It'd be very very hard.
I remember, I mean, when I first implemented an HTTP server, back in, it was before the Beam, we're still using the Jam. It was two,
Mhm.
3 pages of code. That was it. And yeah, it was much more scalable than what was available back then. I think probably 10x more scalable. When they did measurements and benchmarks on Yaws, it was it scaled 10 times more than Apache, and managed a throughput which was 10x. So that was great.
That's
Yeah.
If you're kind of doing
Yours is yet another web server, right? That's what it is.
Yeah, yours is yet another web server. Yeah, so it was the first, non-Inets web server which was implemented. It was part of. It was implemented by some former computer science lab employees who went in and founded Bluetail, which got acquired by Nortel Network. And
Nice.
yours was actually the core engine of Nortel's SSL accelerators, which
Oh,
basically provided an SSL endpoint and to speed up the whole encryption decryption,
wow.
allowing you to get into your backend network in a secure way.
So you can make a case. You can make a case that yours is more financially successful than Cowboy.
It was everywhere as well. It's just a pity that they were never able to cooperate and just focus on one single web server. At the time, I think we had probably there were 4 major web servers in there, 5 including Ericsson's. It was Inex, it was Misseltin, it was Yaws, it was Cowboy, and Mochiweb.
if you're starting to implement your own framework but not really paying full attention, you're kind of doing it a little bit naively. What kind of things you start to actually will break without being careful?
Oh, yeah, many. I don't even. I wouldn't recommend doing something like that. Actually, you know what? That's a good question, Alan. I actually think maybe it might be worth doing something like that for some developers, just to explore something a little different than Phoenix. I wrote the book very heavily inspired by Phoenix, right? So maybe there are other ways to do a web framework. Yeah, you just need to make sure to still focus on results. Still, like make sure you still have a goal, like have an app that you can build with it, so you don't like go in weird directions. But it might be worth trying to just like not look at Phoenix code and building it. People might come to different conclusions.
I mean, while you were building and designing everything, like what kinds of things actually went wrong for you? Because I mean, no way you could knock this out of the park the first time around, right?
Yeah, I mean, like I said, like I had done this before. Like it's something I had given this kind of a talk or demo before, like built it live in like talks and meetups and stuff. So I had a I had an idea. So things overall were kind of smooth. For me, I think it was digging a little deeper than I usually do, so I can understand help people understand those things. Like we're talking about like how Cowboy works and like how a web server works, right? Like whenever I build small version of Phoenix, I'll just like start with Cowboy, right? But here I decided to let's build a small web server with Cowboy. Let's see how Cowboy works. In the second chapter, let's build our own web server. It's a bypass Cowboy. So those were the challenges to like dig a little deeper. and finding a way to explain it to people. The metaprogramming chapter especially took me months. That I wanted to come at it from a different perspective than what people had already done. And I had given like a three metaprogramming talks around that time, and in different coding and Elixir conferences, and I was experimenting with a few different ideas. And that those talks were my experiments with like what registers better to people. So yeah, uh, stuff like that, presenting information in a digestible way and digging a little deeper than I usually do was the biggest challenge for this book.
What do you think was actually harder than you actually expected?
Yeah, it's explaining concepts in a cohesive way, especially when you tie chapters together. That was hard, man. That was very hard. We have reorganized the book. Sorry, go ahead.
Yeah, no, I recognize this, having written a few books myself. It's actually, you know how to do things, you know how they work, but then when you need to explain it, you need to abstract it and, you know, take a step back. And this whole abstraction journey is really, really tough. I don't know if you experience the same.
Exactly. Yeah, that's exactly what I did. I think the whole right now the final layout was HTTP server using plugs, using Echo a little bit, right as a first part, then creating controllers, route and view without any metaprogramming, right? Just like your code, actual code, and then the last layer is hey, let's learn about metaprogramming, and then write DSLs to cover these. Now
Yeah.
it feels obvious to me, but then it wasn't, because you want to go, you want to follow the path of the request, right? And like but you know how do you teach metaprogramming to people? Like, because boom, Radar needs metaprogramming, right? So that making it digestible, making it something while still interesting and challenging enough that people you know tune in and continue reading, that was pretty hard. In fact, Alan, you asked for a copy, right? The when I have the PDF, it will have a little bit different order than the actual published book. So it was like until the last month that the order changed. So it's pretty interesting.
It took me 18 months to, write the last four chapters of Designing for Scalability, where we exposed, Airline and the Beam's secret sauce on how you achieve scalable and reliable systems, because yeah, it just didn't happen out of the box. And take this into comparison that all the other chapters in the book took about a month each to write. The last four, yeah, you really had to stop, abstract, and explain it in a high level way, and it's never easy. So, well done for having achieved it.
Yeah, thanks. They were the publishing company. They were very, very helpful, and they were always kind of available for like a brainstorming session. Pact is the publisher that I went with. They gave me the most flexibility of everyone I talked to. So yeah, they were very helpful. It'd be very hard to do it without someone who has experienced publishing these kind of books, and who has some kind of an idea how users digest content like this,
Nice. Yeah.
or readers. Sorry. Yeah.
Well, what I was
No,
just going to say, go ahead.
okay. I can relate. I think even when, I worked with O'Reilly, the editors were absolutely amazing, and they're always there for you. And I think, yeah, it's a shout out to all of the editors out there. Thank you for being there and for being you.
But coming to something like coming back to like the Phoenix framework, and I haven't gone deeply into your book yet, but I'm guessing that if you're basically going to be copying or drawing a lot of inspiration from it, my understanding about Phoenix is that the core of Phoenix, at least the way I see it, not looking at live view, not looking at channels, is definitely plugs. Not everybody listening to this podcast is a web developer. So can we talk a little bit more about what is a plug? And coming back to that, is plug actually the heart of Phoenix?
Yeah. Definitely. Off the request response cycle, plug is the heart. Controllers are plugs, basically, right? So plugs, it's just a way for you to take a connection represented by a struct, do some operations with it, and spit out another connection, right? That's all a plug does. Controller is a plug. Its job is to get a request from user, could be a content type, HTML, JSON, whatever. Do its operation, get data, and add that content to that connection struct. It could be HTML, JSON, whatever, right? So yeah, and since it's connection in, connection out, they can be piped. You can have a series of plugs changing changing the connection. That's why router is also, well, it's a plug, but it's also, yeah, Phoenix router is more than a plug, right? It's this plug router. Yeah, Phoenix router defines a series of plugs that can be applied to the connection. Like one of your plugs could be, am I authenticated, right? If you're not authenticated, boom, halt the pipeline right there and respond with the connection with the network. Yeah, I think that's probably the simplest way I can explain it. This plug is just a way to take in a connection, transform it, and return another connection.
So does this mean that basically once you understand what a plug is, then the rest of it becomes kind of straightforward, right? Especially with like the construct within the whole plug ecosystem.
Yeah, a good amount of it does. Phoenix does do a few more things on top of it, right? But yeah, a good amount of it becomes very simple. There's the whole Phoenix Cowboy part, the plug Cowboy library, which is like the adapter to use a connection with the Cowboy server, right? Because you need to still plug it into the web server to return, respond through TCP socket they established. There's a front end layer, how you define your HTML and stuff. But yeah, everything that happens within is plug. And great thing about plug is, you have the ability to define functions and a set of functions in a plug, right? It comes with the whole behavior as well. So yeah, I think understanding plug will really, I would say, like 50% of your understanding Phoenix. You'd understand 50% of Phoenix if you understand how plug works, which again isn't that complicated. If you go through the hex docs, I mean, they do such a good job. Another tricky part about writing an Elixir book is our documentation is so good, so we have to add something more than what documentation already gives, right? So, but plug documentations are like so comprehensive. I would encourage anyone listening who doesn't feel like they understand plugs, just read through documentation. It's amazing.
Coming back to you mentioned about basically a controller is also a plug, right? So
hmm
what is a controller actually responsible for? Why do we even have a controller? Why don't we just keep saying this is just another plug rather than saying, okay, we have a controller, we have, kind of like a little bit pushing people towards the MVC kind of style of thinking.
Yeah, I think you don't need one. That's the whole point. I think Phoenix that's where the Rails inspiration, the MVC inspiration comes in. People's minds are already programmed in a way of your resources, and here's an index action, your show action, stuff like that, right? It transforms plug into what people understand already. It'd be hard for people to be like, okay, this router routes to a plug and this one routes to a different plug. It might be trickier for them to manage that, or at least understand that. But that's kind of what router does, right? Like show function in controller is a plug, and they use x.web in controller at the very top that adds another plug. You can add, or gives you the ability to add another plug before and after this show action, right? So it just presented in a more digestible way, but it is plugged within whatever controller does.
I mean, with this kind of, you talked a little bit about like the programming styles and patterns where people kind of used to. That's why we have controllers instead of just saying plug, plug, plug. Where do people usually put logic if they're going to put it in the wrong place, right? When they're building their applications with Phoenix or even their own kind of web framework.
One of the basic ones is like controller have a lot of logic. That's like one of the very first mistakes that people do, putting too much logic in controller. Another one, I mean, I think generally speaking in Elixir, we like to keep our function and modules not super large, right? Like we do it promote that single responsibility principle, or really separating where your logic lives. It makes it easier to manage. It makes it easier to test. If you have too many private functions, if you have too many things happening within one function, it's harder to mock things if you need to. Everything gets very hard to manage that way. So there isn't like one answer for your question, Alan, but one of the places people put, one of the first mistakes people do is put everything in controller.
So more recently, I started experimenting with coding agents, and so I'm actually coding a Phoenix app, and
Like,
it's a really interesting process. Probably done all of the beginner mistakes. You're trying to do too much too quickly, having drunk the Kool-Aid instead of having a cyclic, iterative approach. If someone's Phoenix app is a mess, what's the most common architectural mistake you think they've done? And also, how should they approach Phoenix if they're working with coding agents?
A very, very good question. So coding agents till now, my experience with Elixir has been not great in already existing Phoenix apps, right? With new ones, they do tend to do better. I mostly use Claude, Opus, and Sonnet for the most part. And new apps, if you start with it, if you give it instructions, if you have like Credo set, if you have like proper CI formatting, all the rules set, whatever you can automate. Obviously the coding agents would follow that. The MD files instructions, Claude has Claude on MD. Those things help a lot. Linking the Elixir best practices, right? All that helps. Now, the biggest mistake that people have made designing Phoenix applications, or most likely mistakes that I've seen, and I think Claude and coding agents also do, is it's overcomplicating not just a function, actually overcomplication in general, right? It could be overcomplicating a function. I think Elixir Erlang having the ability to start processes, overusing them, starting processes for no reason, infinite timeout on live view. That's like very common, just keeps happening. Handle info does a call to an API and oh, the task timeout is infinite. Yeah, that's not gonna work with live view, right? So stuff like that. Sorry, and handle event. So yeah, stuff like that. Just it's especially with live view, I think it's complex enough that it matters that what your code does. With controller, each action is isolated, and uh, even a simple web server in Elixir has like some scalability. So you probably won't be blocking actions, right? Live, for example, is a process, one process, right? And if you have like a blocking action or process, you're like halting the rest of the you know functionality of live view. It won't respond to any other messages and stuff like that. So yeah, I think, sorry, overcomplication at a high level. I've seen new developers and also coding agents do, because Elixir is so powerful. So, like it makes processes and concurrency so easy, and people just drink that concurrency Kool-Aid too soon and just spin up processes without any thought to like the consequences of that.
Exactly. That's something which I keep on. Yeah, I keep on telling people: be careful. You want the process for every truly concurrent activity, and not for say every session or everything which makes it appear like it's concurrent, but in fact it's not. Current activity is an event, or it's a message coming in, or it's an external stimuli, and it's not, or it's an
Yep.
HTTP request. It's not necessarily. And obviously, you'll need a process, for each WebSocket which you have open. But then, when the requests are coming in, that's when you go in and you spawn new process. With this in mind, what patterns, from the book actually did you find hold up in production, which you discussed?
Yeah, I think the book is a majority of the book is not production code, right? Like we're building our own web server, we're building, our own framework. I don't expect this is not a production ready framework by any means that we're building. The stuff that I think it teaches people about production code is, well, first of all, everything is, I always add unit tests at the end of the chapter for every single thing we do, even if it's something that people might think is not worthy of testing or would take a lot of time to test. There are ways to test it somewhat, right? So I'm trying to I cover that at the end of each chapter. And I think the metaprogramming chapter, I mentioned it before earlier in the podcast, that I'm quite proud of. It's something I actually talked with a few people in the community. Andrea Lepardi, I think you guys had him in one of the previous episodes.
I'm
He
seeing
he
him
told
on
me,
I'm seeing him on Friday. We're
nice,
actually
nice.
meeting
Oh
in
yeah,
person
yeah,
on
yeah.
Friday. We always meet all over the world, North America, South America, across Europe, but never on our home turf. So yeah, we're actually seeing each other. It's
Nice,
very unusual.
nice. But yeah, Andre is pretty awesome. Shout out to him. He was very encouraging when I was thinking about writing the book. But he mentioned it with metaprogram in particular. Like if whenever you talk about it, you have to also talk about when not to use it and why it's risky, right? So stuff like that, like making sure I explain why metaprogramming works the way it does in Elixir. And trust me, like we do metaprogramming in the book without even using macro. And And you don't need to use macros. Macros is an abstraction around metaprogramming that Elixir can do, right? So stuff like that I cover, but obviously there's 2 or 3 parts in the chapter, and that one chapter where I explain this is not a good place to use it. This is not a good place to use it. This is a good place to use it, but let's test the non-metaprogramming part really well and make sure metaprogramming is just an abstraction around that, right? Like it should not do any business logic and stuff like that. So I think if people find themselves in a place in production where they have to put metaprogramming, which happens every now and then, right? It's rare. I think this chapter pretty much covers it. That's a chapter I'm most proud of.
Now that we're talking about metaprogramming, let's talk a little bit more about that, because you have this metaprogram, and I think it's okay as long as you can kind of understand what's going on. Maybe you don't need to know the intricacies of what's going on exactly, but was there a point when you're looking at all this metaprogramming and things that plugin Phoenix brings to you, and you're just saying, it's got this aha moment, like, oh, that's what Phoenix is doing. Like I had no idea that's what that like macro was actually doing.
Yeah, the first time I read it in 2020, that's when I had the aha moment. Well, I had the aha moment in Ruby and Rails first. Right? The metaprogramming Ruby is a lot more heavy, less predictable. Is the best way to put it. Elixir really constrains you in what you can do with your metaprogramming and how much you can mess the state of the already defined functions and modules. It wasn't as of an aha moment, but it was still a little bit, especially the router DSL. It's I don't remember all the details anymore, but it was it was more than just a simple metaprogramming DSL that hey, this router is an abstraction around if you write these functions this way, which is what metaprogramming generally tends to be, right? Like the ecto schema, for example, amazing, probably the best example of metaprogramming in in the community of all the packages. I think Absinthe is pretty good too. But Router DSL was a lot more than that. I see it's so complex I already forgot, but I remember it wasn't just hey, here's a pipeline and that gets translated to a function. No, it was more than that. It was using another process which was keeping track of things, and that was getting like flushed into something else. I don't exactly remember. It was like more than just hey, this translates to this non-metaprogramming code. So that part was very eye-opening, and I chose not to do it that way in the book, but I'm sure Chris had a reason for doing it that way.
What is your biggest misconception when it comes to macro?
That's a good question. I think I think people might not know what macros really do. All they do, they are just a way for you to change your AST. Macros are functions for your AST. That's what they are. And they get called as your code is getting interpreted and during compilation, and obviously they change how your code gets compiled. I think ordering matters with macro, like how you define things, the module attributes where they're defined and stuff like that, they matter. And macros can call functions, right? If they're already defined. Again, they're pretty simple. They're just functions that change your AST. I think that's probably the best way to put it. That's one of the reasons why in that chapter we changed an AST without using a macro. This is how a macro works for the most part. There's more that a bit more that it does, but we basically write macros like how a def macro would work before even using macros. So I think that was probably like kind of a way to let people know that macros are simple. They're just functions that change your AS.
When is metaprogramming and macro writing like the right tool for the job? When do you think that?
I'm sorry, come again. I lost you for a second.
Yeah. When is metaprogramming and writing macros the right tool for the job?
Yeah, I think that's a good question. So for 99.9% of cases, it's not, right? That's what everyone says in the community. If you find yourself doing something a lot of times and it's complex enough that it's intimidating for people to start doing it, and the cost of that code having bugs is not super high. I think it's an intersection of these cases. That's what I believe. So unit tests are great place to try out metaprogramming. If one of the first places I put this was I wanted a way to test if a controller has if all the controller actions have an authentication layer to them, right? Whenever we write a controller action, not always a developer goes and tests, hey, whether this call was authenticated, right? I wrote a DSL to interpret the pipeline, and as we make a request to the controller, we capture what all paths we've tested. And if we did not test the odd path, that test would fail, right? And there was a DSL, just hey, test with auth, right? Just that ensured that this action is tested with authentication, right? So there's two parts of it. If developers did not write it, a unit test would fail, letting them know that they have to write it. And there was a DSL that made writing the test easier for them. So this was I think, a great place to use metaprogramming because it's test your production code, will not fail because of some weird bug. Because metaprogramming code tends to be of higher order of complexity, but it also added value, adding unit tests that people would generally skip, and making it easier for them to both catch that they skipped it and also write it. Do you agree with that, Alan?
Yeah, that makes sense. I'm also thinking myself about like there's quite a bit of like DSL in terms of how we write. At least like the router and there's a couple other things too within Phoenix. Of course, Plug too. How much of the Phoenix developer experience do you think actually comes from its own like DSL?
All of it. Yeah, I think that's the whole idea of writing this book, right? Like I think we wouldn't need to write this book if a good amount of the experience wasn't through DSLs and macros. Yes, I would say all of Phoenix experience comes from macros. I think maybe besides some of the oh, sorry, I'm hearing a lot of noise. Maybe minus the HTML part, the Heeks part. Well, actually, EEX was less DSLE. Heeks is actually very DSLE as well, the metaprogramming. So I guess yeah, all of Phoenix experience is the experience of the interface and less of the implementation. I don't know if you guys agree.
No, it makes perfect sense. I mean, and in this, there's a question which is kind of spinning in the back of my mind because if you look at it, metaprogramming has been part of Erlang since its early days. It's always been there, but they have on purpose made it very inaccessible and hard to use for a reason. It's using some core library, needs the web server, Mochiweb, used to use it, but developers never, ever, ever used it or wrote with it in production. Never used it in production code. And the reason for it was maintainability of the code base, maintenance of the code base, where, I think we always had the motto, be nice to others, be nice to others who are maintaining your code because it could be you someday.
Yeah.
And for this reason, I think one of the reasons they invented Erlang and one of the reasons where, Erlang reduced the size of your code base 10x, compared to at the time your conventional programming languages such as Java or C++, is maintainability cost. And they knew very early on that metaprogramming and kind of high level DSLs would increase that cost. So I think you said the right words there. You said the right words earlier, which was okay. Now I forgot what was. Now I've lost the thread here. You had said should take a note of this. 1 second. Let's So I'll dive straight into the question here. So yeah, no. So to go in and reduce maintenance costs, it was a no-no. My question, to you right here, in this regard, do you feel metaprogramming makes systems hard to debug in production? Because you get an amazing visibility with the Beam. That was one of the ways of reducing the maintenance costs. Has it in the Elixir space made it harder?
Yeah, absolutely. The way it is, it has. I think we can add things to make it more transparent. One of the things that I've done in the past is, well, first of all, sorry, I'll take a step back. Like I said earlier, try not to even write metaprogramming in production code, right? Like use it for like code that is not in production, like the test example that I gave. But if you don't have any other, way around it, you need to make sure your metaprogrammed code and the code generated is transparent. You need to add, because since it's less runtime, more compile time, adding those compile time markers to the code. Ecto again is a great example. It has those reflections, right? Like you can always, boom, I can go into production, open an IEX shell, right, and do this ecto schema dot underscore schema underscore fields, right? Boom, I can get the results of metaprogramming after it's applied. So the more of those reflections and like those helper functions you can add that might help people debug, make sure everything is correct with the interface, the better it is. Secondly, if you are deploying production code which is less transparent because of metaprogramming, it's on you as a designer of the DSL interface to also write tests. Again, metaprogramming is compile time. We should not be relying on catching things at runtime after the image is built and deployed production, right? Like again, Ecto, I think probably doesn't have that good test in here in my opinion. It has a lot of examples, which is great, but adding your test for your reflections as well, like that's where those functions, when you generate, you can be like, hey, these functions pollute my code at production. You can only generate those functions and tests or dev environment, right? And disable them in production and use those to properly test your interface. So I think when you write a DSL as a library or a part of production code, whatever, make sure you also write a, a nice interface for testing them. I'm trying to come up with examples, right? Absinthe is great. Absinthe is so good, actually. Yeah, I remember Absinthe had like unit tests for every DSL that they added. They had ways to the test helpers for each of those, so you can like really test your DSL thoroughly without and end-to-end tests are important, obviously, right? Like, but you're more prone to missing edge cases the more end-to-end you go, right? That's where those test helper to test intermediate parts of that DSL will really help. Yes, and anyone listening to this interested in metaprogramming, both in DSL design and also how to write those test helpers, check out Ecto, obviously the code for Ecto, not just the documentation, and check out Absence code as well. That's a GraphQL library.
Have you seen a DSL go too far?
Yeah, many times. Yeah, more so.
Can you give concrete examples? Let's not mention names, but just
Yeah,
surnames. Yeah. No, but when you've
I'm
seen
trying
it
to.
in production, yeah.
Yeah, I'm trying to think of an example that would not be obvious for people to associate a name with. Yeah, I guess one internally. You know what? I did it once. So how about that? That's the best. Taking my example. I did it as a junior developer in 2016-17. We were writing like a PDF processing library. It was an application, and we were processing like different PDFs as part of a healthcare company, right? Different tax forms and stuff like that, right? So I wrote the whole PDF schema as a DSL, so we could just like you know write those schemas for other PDFs and have a nice DSL to process them. But the PDFs schemas kept getting more complicated. The requirements kept changing. The fields kept getting more. You know, hey, this field should not be there in page 2. This field should not be there in page 3. Right? As that complexity kept increasing, I also wanted the DSL to handle that. But the more complex the DSL, the double the complex the implementation, right? The actual logic for that. So there were quite a few bugs in that. So yeah, that's a classic example, right? Like the intention was right there. You can say, I guess, right, that we keep writing these schemas. I just want to make sure it's easier to handle new PDFs through this DSL. But the more generalized your DSL becomes, the more complexity it needs to handle, right? Because I want it to be flexible. I want it to be able to handle all these constraints that I mentioned. Yeah, definitely wasn't the right decision. Hindsight would have not even written a DSL at all. Represent the schema as a new module for each PDF. It's not that much effort to write a new module and just your bottleneck. I don't know, just the bottleneck is still like the actual processing, right? It's not the schema. So you just have to copy paste and you have a bunch of modules that are copy and pasted. Sure, it's not great, but at least it gives you flexibility to change those modules individually without changing the DS.
So I think, yeah, we're heading, towards the end of this podcast, and yeah, we've got the theme of, should you ever do this in real life? Who should actually go in and build their own web framework?
Anyone who wants to learn, I think that's probably it. I would say I think we already have enough good options in the community. If there are things you want to improve on Phoenix or other frameworks, contribute to them, I would say, instead of building one. And if obviously people aren't open to contribute, that's a different conversation. But I consider building framework for 99% of people who would learning exercise, so they can go and contribute to
Okay.
Phoenix, learn about it, and like evolve, grow as a developer. Yeah.
So I've not really been involved in the JavaScript community, but why are there so many frameworks? Which, it's almost like they were inventing a new framework every week in the JavaScript world.
Yeah.
Why was this happening?
I don't think I have an answer to that question. I think it's just people's desire to have custom stuff. I'm sure people who build some of the significant frameworks had a reason, but I definitely lack the context to give you a proper answer there.
Okay, coming to conclusions now. When does it make sense to go lower, on a lower level than Phoenix?
Yeah, I think learning is a great example. If you find yourself where Phoenix is becoming more of a hurdle than of productivity, booster, that's when you can explore lower level things. Like if you want to build a very simple web server that just does something super simple, you don't want all the you know overhead of having Phoenix. Like Plug could be an option. Plug with Cowboy, right? Plug Cowboy is the library that Chris McCord built, I think, and that hooks up your Plug with a web server. That's probably a reason. Even lower level than that, I don't see a reason.
Okay. Why is Cowboy being phased out, and how will it impact a legacy Phoenix app?
Sorry, I missed your first part.
So why is Cowboy now being phased out of Phoenix, and how will it impact legacy Phoenix apps? Because I think that's a major change.
Yeah, I think at least at a high level, it should not impact Phoenix apps because it's just a dependency that you're replacing and a few reference. I think it's being phased out. There's, I think, two reasons to it. One, I think, is a little bit more, for lack of a better word, political and controversy related a little bit, but there's also performance optimization that have been done in Bandit and Thousand Island. I think that's also a big reason. I think Cowboy has been kind of in the process of being phased out on since 2021, right? Or 2020 even. Yeah. Bandit and Thousand Island have performed a lot better than Cowboy and Ranch, especially the Ranch versus Thousand Island in their ability to manage those socket connections. So I think that probably is the justification of switching Phoenix to Bandit. But again, we've done that for our Elixir projects in my company. I've done it for my side projects. It's like a 15-minute change.
So coming back on this book, right? As a developer, we try not to reinvent the wheel. If there's already existing something, some kind of library, we try to use it. Coming back on this question, it's basically what I want to ask is, what's one mistake that developers make when they rely too much on a framework and not on, say, something else that may solve the problem that maybe better fits it?
Yeah, that's a good question. So I think that's in general, if a framework or library is evolved enough, it's used enough, it should handle 99% of the use cases, right? Now, your question is about that 1% of the use case it might not handle well. Alan, is that correct?
Yeah.
Yeah. So I think that's where the intention of writing this book is coming from too, right? If you understand Phoenix a little bit more deeper than just the TSLs, you would know that this particular case might not be handled well with you know the way Phoenix is right now, and that will allow you to, hey, maybe I will bypass Phoenix, or maybe just use a router to this one plug, and that the rest of that action will be independent of Phoenix and stuff like that. So yeah, I think I mentioned convention over configuration for Ruby on Rails, and how a lot of people use Phoenix like that too. But that's where that configurability comes in. Phoenix built on plug allows us for some of that configurability, right? And there are ways you can completely bypass even the router in Phoenix. Still, your main app using Phoenix, you could still have two web servers, and that one web server be the catch, be the first catch, and can like filter out certain requests, right? There's many ways you could like bypass that, but I think knowing the framework is important to make that decision, that whether what you're trying to do would the framework be able to handle it or not. But for most cases, a framework like Phoenix that's like so ubiquitous, it should be able to handle it. Hope I answered your question.
Now, if someone reads your book, what do you think that would change their mind about how they actually build systems?
Yes, the feedback that I've gotten till now has been, I think it has encouraged people to look into the repos of Elixir packages, not just Phoenix. I think when you read, even without coding live with the book, right? If you just like read through it, it kind of demystifies everything one after another, right? And then we show the DS. It shows people that even one of the more complex libraries framework in Elixir Phoenix is so accessible, and that encourages them, that like kind of opens new doors for them to like, oh damn, I could go and like read this Ectos code now, right? And understand how that library works. So I think that is the feedback I've gotten. It's changed how people, view a library as instead of a black box. It has made the encourage them to, you know, look a little deeper, because they gain confidence or whatever, from knowing how Phoenix works. And the other one, I've gotten a lot of emails and messages about the metaprogramming chapter, especially being able to change the AST without using macros part, and then using macros on top of it. Like really it makes it so clear how, like what macros do, how they work. So yeah, those are the two big messages I've gotten. Yeah. I don't think I was expecting people to really even read it. I was expecting maybe 1,500 people to read the book, maybe, but not expecting so many people to read it and like send all these messages and stuff. So yeah, very. I remember I was telling you, Alan, when I launched 3 years ago, I was overwhelmed with and humbled by all the messages I got. It was amazing.
Nice. So, are there any tools you might have used to write the book? I mean, I go back and think, integrating book and code is never easy. I know Joe Armstrong went in and wrote his own, wrote his own tools, when he was working the second edition of Erlang programming, which, he tried to get Pragmatic to adopt. When I
Yeah.
wrote my first book, not a chance. I think I used Microsoft Word. Second, then I wrote a chapter, the architectural, the architecture of open source applications. I think I used Emacs for that, and there was a bit of code in there. And then designing for scalability, we ended up using Oxygen. So again, really,
Hmm.
really hard to integrate it. How did you do it?
Great question. So yeah, I looked for tools that are available. So I guess let's take a step back. Here's the problem, right? If you're writing a coding book, you're used to writing, Markdown and stuff. Like obviously, right? That's a big shift to like use like Word or all the text, all these like text document editors that most publishers still use. They don't have a custom tool. Pragmatic has something free. Matthias, who wrote Testing Elixir with Andrea, he showed it to me, and it was pretty cool. But it didn't look like it would. First, it's proprietary to them, and that didn't look like it would be satisfactory for me. So a big challenge for me was I wanted all my code to be 100% tested, but I also wanted exactly that tested code to be in the markdown that I was writing, right? So basically insert. So I wrote this tool that ensured every piece of code that is in the book, it points to a real file or a real project, right? Every thing is a repo, and that code is tested, right? If that wasn't tested, my CI for generating the book would fail. I wanted people who read my book to have that experience where they can just copy and paste the code and boom, everything is up and working. So that was the intention behind writing this. Yeah, but a couple of my friends also helped me. Josh Adams, I'm gonna give him a shout out here. He helped me with this too. So it was very very interesting to do something like that. Basically, how we have EEX embedded in HTML. There was a tag in the Markdown that I added. Insert code here, basically, and the book generator would insert that code and make sure the code is tested. However, at the end, just to mean shade to pack, but I think they decided to not use the final generated PDFs. They have their own constraints, right? So then they copied and pasted stuff, and things got bungled. They missed a line break in a page and stuff like that. So it wasn't really as successful as I was hoping for, because it kind of defeats the purpose of writing that library. But yeah, it was still fun to write that.
Well, now that you've kind of, you've been using Phoenix for a while, you wrote the book on how to write kind of your own Phoenix. Do you think frameworks are making us more productive, or they're taking us kind of further away from what we should be doing as a developer?
Oh, more productive. hands down, especially something like Phoenix by a huge margin. Maybe there are some frameworks that, might cross that line, but they wouldn't be adopted at a level that Phoenix is. All the companies, all the startups, their goal is to be super productive with their time. And the ones that have finally adopted Phoenix, they've done that because of the productivity boost that it's giving. And yeah, I think there are, like I said earlier, there are hurdles because of that lack of transparency, at least apparent transparency. Books like Programming Phoenix and this Phoenix Live ebook, oh my god, that's such a good book. Like those books really do an amazing. You don't even need to read my book. Like the because my book goes a little too deep. You don't even need to go that deep. Programming Phoenix and Live ebook will give you, enough context to, I feel, be a very, very good Phoenix engineer.
That you've been using Phoenix for a while. Again, you wrote the book on how to make your own Phoenix. If you were to make a Phoenix 2.0, let's say that Chris wants to retire, right? He's all about durable server and not about Phoenix anymore, since we just had the discussion with him, and he's ready to kind of move on to something new. What would be your Phoenix 2.0 if you were to say, like, if you had the possibility to say completely rewrite it or make some major overhauls to it? What would you be? How would you want to do that?
I'm gonna give a very boring answer. I'm gonna keep it the way it is. That's incredibly successful. It'd be very arrogant to even think that, yeah, I could make a change that could help Phoenix. It's incredible. It single-handedly helped with adoption of Elixir and Erlang in a way that we wouldn't be using Elixir or Erlang the way we are without Phoenix. I know a lot of companies were using Erlang before and stuff, but the inflection point that happened in last 10 years, it's because of Phoenix. I think it at least, or it's one of the big reasons, right? I wouldn't really change much about it. And like I said, no code is perfect, right? There are some things in Phoenix that I'm sure Chris thinks that would be great to change, but I don't think rewriting it would yield any more perfect code than Phoenix, or any less. So, yeah, probably not the answer you were looking for, Alan, but
That's some really, really good food for thought. Thank you for that. And just for the record, this episode was recorded on May 6, 2026.